So guys, we are going to discuss a problem coins combination 2, and we are going to discuss the recursive approach for it first, right? And so the question is pretty straightforward. We are given n number of coins, and we have to make a desired sum, right? So as we can see that for 9, there are three ways, right? 2 2 5 and 3 3 3 and 2 2 2 3. So we can see by the problem statement itself that we can use the like the coins multiple times, right? So yeah, so let's start with the recursive approach for this problem. So yeah, first what we are doing is we are just basically taking the input here, right? And then we are just initializing the dynamic programming matrix with a value which can never be the answer, right? And just calling our recursion, like give me the answer to make the value x, and currently I am at index 0, right? So let's see what happens in the recursive function. So what we are doing in this function is fairly simple, that so first of all, if let's say our x at any time of place is less than 0, so it's an invalid path, right? So we will just return 0 over here. And let's say if we are at the end of the index, so if our x has become 0, that means that we have the desired sum in our hand. So we will just return a 1 because it is a valid path. Otherwise we will return 0, right? It is standard, like if that answer is already computed, then we will just return it. Otherwise we will try to compute it, right? Let's say I am at like I am at 9, right? And I am at in the like 3, right? So what is the possibility? Either my 3 would be taken or it would not be taken, right? So what I will do is, if in the case of not taking it, the my index will go ahead and my x will remain as it is, right? And let's say if I want to take it, so what will happen? I will just subtract the 9 minus 3. Now I want to make this sum out of the remaining. Now please note here that we are not increasing the index. Why so? Because the repetition is allowed, right? So why? Because 2 2 2 and 6 and 3, right? So it is 9, right? So what we are doing is basically we are taking the 2, then we are again taking 2, and then we are again taking 2. So it is possible when we do this step again and again for the index 0. So it is taken here, right? Because as I have already said that in the problem, that we should see whether that path would be whether that part would be there or not in our problem, right? And we can see that all the paths would be covered, because even if there is a repetition, it is like accounted for, right? So yeah, so I hope like this is clear to you all. And also talking about the time complexity, first of all. So time complexity here is n into x, and the space complexity also is n into x for the DP array, and also the stack space would be n into x over here, right? So let's try to submit this problem. So guys, as you can see, we are getting time limit exceeded, although our solution is right, but obviously a recursive solution is sometimes slower than the tabulation one. So okay,